Hi there. It is January 9th. I hope you are doing well. It is rainy. We spent the last couple of days dealing with had two horse shelters blow down and roof tiles fell off of our shed. I spent all day yesterday repairing fences and breaking up the sheds and putting them in piles and getting a spot to put my tractor. The first windstorm last week actually blew my tractor over on its side. That's how strong it was. So buy a farm jack if you need one. If they are the best thing to flip tractors back over on their sides, because otherwise they're too heavy for a person to lift. Anyway, so today, what are we doing? The answer is some of you are at home hanging out going, it's too cold outside. Actually, and some of you are at home going, it's too cold outside and I've got to do work because the trees are on the fence. And that's probably good. So I don't really blame you for being home. That's okay. But you have work to do. And so we are going to focus on this kind of 1 weekish thing. I don't think we'll spend a lot of time on it, but I want to cover this. In a math book, you usually see this, but you actually see it in science class all the time. It's called scientific notation. Da, 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 da. Now, what is scientific notation? The answer is it's all sciency. No, what it is that when things are really small or things are really big, little small, like smaller than a dot, or really big, like as big as a planet or the universe, you have to deal with number systems that are just too difficult to work with. For example, if I were to say, okay, what is the size of these two lines? Well, it's about 2/3 of an inch or 1 centimeter. Centimeter is a little bit handier than 2/3 of an inch because you can do decimals with centimeters. So when things get really small, we stop. With inches, we say, well, okay, here's an inch, and then there's half an inch, there's a fourth of an inch, and there's an eighth of an inch, and there's a 16th of an inch, and there's a 32nd of an inch, and there's just, and you start getting to where 64ths of an inch, and you don't really measure things in inches much below 1/32. They just don't do it because it's not simple. So what we use is metric, and that's a centimeter. 100 of those is a meter. A meter is about a yard long. Take a big step, and that's a meter. And if you, at some point, you'll be wanting to date all you guys when you get older. And so you need to get one of those. They're called a meter stick because if you don't have a meter stick, you will never be able to meet the girl of your dreams. That's why they're called meter sticks. So you wave it up in the air. It's called a meter stick. It says, "Hi, I'm available." It works really, really well. You can guaranteed catch all the dates you ever want of science nerds if you wave a meter stick in the air if you're a guy. Okay, now when you get married, this is a little bit different. It's not as hard. You don't have to do much. You just get those things that are 12 inches long. And what are the 12-inch ones called? They're called rulers. So you have a ruler because once you've met her, you've already married. You just have to learn to ruler instead of meeting her. Yeah. So don't share that one with your parents unless you really want to get the old stink eye. But it has worked for me. Just don't tell Lynette because she will not go with the, oh, you think you're the ruler. No. Anyway, so what is scientific notation? Well, it's something that's really, really small or something that's really, really big. And it's generally in metric is what you deal with. So, for example, let's talk about the if you were to be in America, let's go with Somerset, and you were to drill a hole straight through the earth. So here's Somerset, and go straight through. You would end up somewhere in the Indian Ocean. No, it's not China. The Indian Ocean. China would be like over here. So you go straight through, you'll be in the Indian Ocean. And what is that distance? Well, you can go, well, it's about 4 miles, it's about 12 miles, and it starts getting really big. And so what we do is we say, well, it's actually 6.4 times 10 to the third kilometers. That would be how you would say a typical science book. They could say, well, it's somewhere around 7,000 miles, 5,000 miles, no, 3,000 miles. I don't know. I'm good at metric when things get big, but nobody ever does the mile thing when they get really big. It's always metric. If you're say, okay, well, here I am on Mr. Earth, and I'm going to go to the moon. Well, for 3 days, 3 days, you got to travel at 25,000 miles an hour. And so you got to start multiplying big numbers, and it becomes harder. And these numbers become very, very big. If I were to say, well, okay, and over here is the sun, Mr. Sun, wee. Sun is, he's happy. That's why he says wee. Every time you draw the sun, you must say wee because the sun is happy. Have you ever seen a sad sun? No. If it's sad, it's called a cloud. Otherwise, it's called the sun. That's why the sun is happy. Anyway, you start going there, you would be traveling for months to get to the sun. You'd be going, I think it is, when we're at our closest, I think it is about 6 months to get to Mars. I mean, it's pretty far at going at a pretty good clip. By the way, most spaceships go about 25,000 miles an hour. And if you didn't know that, now you know, as Bill Nye the Science Guy said. So you start dealing with big numbers. Well, what about if you are in our little solar system? There's Mr. Sun, whee, and there's the Earth, and there's the moon. And you want to go to the nearest star. Well, how far is that? That's going to be a couple of light years away. Well, you can't just say, well, that's going to be 600 billion, 942 billion. You just don't use those. Big numbers require some other way to deal with it. Small numbers also require some other way to deal with it. So what you're getting from me right now is a lecture on why do we use scientific notations. And this is what you're going to take away from it. Big numbers and small numbers. If you're talking about how far is it to my aunt's house, you're probably going to use miles. If you're thinking how tall is my brother, probably not going to use miles. You'll probably use feet and inches. If you're talking about how many gallons of gas your car holds, it's going to be gallons of gas that your car holds. It's not going to be billions of gallons or scientific notation-y things. It's just going to be a simple number. But when you talk about how much water is in the ocean, you're going to use scientific notation because that's a lot. If you think about how far away is the next planet or the next solar system or the next galaxy, you can't do that in regular numbers because they're just too big. And that's the thing. Likewise, when things are small, things get below about a 32nd of an inch, or in metric, about a millimeter, you start thinking, I don't know. I mean, you can measure things in a millimeter, which is fine. That's a millimeter is 1/1000th of a meter. That's like you haven't really met the girl, but you saw her picture once in a yearbook. That's like 1,000th of a. That's why we call it a millimeter. It's not really a full meter. Anyway, I digress. Then we have what is called a micrometer or micrometer, and that's going to be 1/1,000,000th. Well, now it gets really hard to write. And then, or something that's a billionth, a picometer. That's 1/1,000,000th. That becomes much, much harder to deal with. And so we stopped using regular numbers pretty much about here. Anything smaller than that, we go to scientific notation. Okay, so that's the deal. So, for example, how big is an electron? Or let's say how big is what? Let's go with what is the electric charge on an electron? I'm trying to think of this off the top of my head. How big is an electron? I think it's 6.4 times 10 to the negative 23. What that means is it's really small. Okay, I'm going to explain to you what this number means or what that number means. And that's actually not that difficult. Once you get it, you'll get it. So here we go. So first question was, what is scientific notation used for? The answer is it's used for things that are big or small. Okay, how big? Bigger than you won't want to write a bunch of numbers. Smaller than 32nd of an inch or smaller than a millimeter. That's when you typically use scientific notation. So what does this mean? I'm going to pick a number and I'm just going to do some random ones. I'll use ones from your book. Let's say you have something that's 5 times 10 to the fourth. What does that mean? Well, 5 times 10 to the fourth is how you would write it. We actually say an x on this. It's not 5x 10 to the fourth. It actually means 5 times 10 to the fourth. This is, everybody knows and understands when you see this, that is scientific notation. Something times 10 to the something. Well, y'all know what a 5 is. What's 10 to the fourth? 10 to the fourth is 10 times 10 times 10 times 10. You will notice conveniently some patterns here. How many zeros are there? 10 to the fourth. 1, 2, 3, 4. Ooh, 10 to the fourth. Let's try another one. 2 times 10 to the second. Well, you know what a 2 is. Times. 10 to the second is 10 times 10. How many zeros here compared to that? Ooh. Okay, well, let's pick one you know, just so you... What is 10 to the second? Well, that's 100. How many zeros there? There are 2 zeros, 2 zeros, 2 zeros. These numbers are kind of, they all go together. So when I say 10 to the fourth, what is that? That's 10, 1, 2, 3, 4, or 10,000. Okay, so that 4 represents what it is you're multiplying it times itself, but it also is conveniently how many zeros are after it. The 1. So it's a 1 and then 4 zeros. So just to make sure you got that, do another one. 3 times 10 to the ninth. Okay, without writing 10 times 10 times 10 times 10 times 10 times 10, that's equal to 3 times what? 10 to the ninth is 1. Okay, 1, 2, 3, 4, 5, 6. You got to do it in that voice, otherwise it doesn't count. 7, 8, 9. Okay, and then you put your commas in later. Oh, that's a billion. 10 to the ninth is a billion. Wow, ain't that special? And so this is a shortcut way of showing what that is. Now, to write it in scientific notation, really what you're doing is you're just saying, this is what that means. It's 3 times 1 billion or 3 billion. That's what that means. 3 times 10 to the ninth is 3 with 9 zeros behind it. Ooh, isn't that convenient? 2 times 10 squared is 2 times 100. What's 2 times 100? It's a 200. Is a 2 with 2 zeros behind it. That's what 2 times 10 to the second means. Or 5 times 10 to the fourth is 5. How many zeros? 1, 2, 3, 4. Now do your commas. 50,000. That's what it is. So this is how you go from a scientific notation-y thing to regular numbers. That's what it means. Now, what will often happen is that they will give you stuff that is big, but sometimes they will give you stuff that is small. So for example, what if I say 7 times 10 to the negative 2? What does that mean? Well, there's rules on exponents and all that kind of stuff. Nobody remembers them unless they're math people. That's okay. But you will remember this because I'm telling you. Because you're special and smart and it's not that complicated. So what this means is instead of saying like 10 to the second, 10 to the second power is 100. That's a 1 with 2 zeros. This one is 7 times, I write 0.12. In other words, I count my zeros backwards to the left. 10 to the negative 2 is 1/100th. 10 to the second is 100th. Remember that. 10 to the 2 is 100. 10 to the negative 2 is 1/100th. 1/100th is, remember the decimal points? Tenths, hundreds, thousandths, 10,000ths as you go across. That's what that means. So 7 times 10 to the minus 2 is basically, I put the 7 wherever that first, I just multiplied that times that. So this becomes 0.07. So instead of a 1, I put that number. So just in the same way up here, instead of a 5, or instead of a 1, 10,000, I put the 5 where the 1 was. 2 times 10, instead of the 1 for 100, I put a 2 where the 1 was. That's how I got 200. 3 times 10 to the ninth, it's 3 with all those zeros behind it. So it's whatever this number is with that many zeros behind it. When you have negative numbers, it's whatever number that is with that many zeros to the left. And you always have to have a 0 point. That 0 counts. Okay, so let's do another one. So let's say I have 3 times 10 to the minus 5. 3 times 10 to the minus 5. Okay, that's going to be 0 point. Okay, that's 1, 2, 3, 4. How many zeros am I supposed to have? 5. And then a 3 instead of the 1. Okay, so it's that many zeros. 3 times 10 to the minus 5 is tens, hundreds, thousands, 10,000s, 100,000s. Okay, so this is 3 100,000s. 10 to the 5th is 100,000. 10 to the minus 5th is 1 100,000th. Okay, in this case, 3 times that would give me 3 100,000s. You get it? One more. Let's go with 2 times 10 to the minus 4. Okay, 2 times 10 to the minus 4 is 0.000. Now I have 4 zeros. Remember, I got to put this one. And then 2. That's it. Tens, hundreds, thousands, 10,000s. So this is 2 10,000s. That's how you do scientific notation. And you're writing them this way instead of this way. You can imagine 3 times 10 to the ninth is a lot easier than writing 3 billion. Or that's just there. Now, if you start talking about the mass of an atom or things like the nearest star, things that are really, really small, you can't be writing those big old numbers out. It just is ridiculous. So you write scientific notation instead. So on page 215 in your book, page 215, you will see kind of a simplified version of that. And then I'm going to go through a couple of the examples. You got to be able to do one or the other. Plus, I also have, what if it's a decimal? So let's say, for example, there are 4,200,000 people that visit the Statue of Liberty every year on a good year. Okay, that's a lot of people, but hey, you say visit the Statue of Liberty, that means they like go there and take pictures and stuff. But let's pretend you have 4 million people that visit the Statue of Liberty every year. Let's change that into scientific notation. The way you do that is you take this number and you just write it as a decimal, 4.2. Okay, so we kind of go from where the point is here, and we count, instead of zeros this time, we go 1, 2, 3, 4, 5, 6 times 10 to the 6th. Or I could write it as 42 times 10 to the, and I just count the zeros, 10 to the 5th. What we typically do is we write it this way. Scientific notation always does the decimal after the first number. So while in my previous examples, I didn't have any decimals, and I didn't have any other numbers other than the first number and zeros, it all worked fine. In actual scientific notation, typically you have the point there rather than just writing it as 42 times 10 to the 5th. This is actually true. There's nothing wrong with that, but it's not scientific notation. There's a couple of ways that people write things. You'll notice that, for example, there's 3 here, then 3 here. When we start counting, we go by groups of 3, and we put the commas. There's actually a thing called engineering location, or engineering notation. So this would be scientific notation, and it's also engineering notation. Engineering notations always have a multiple of 3 here. So we're dealing with scientific. Don't worry about engineering so much. Well, so for example, 49,000 in engineering notation is 49 times 10 to the third. So we only count them in groups of 3. And so we leave that as 49. If we had 4,900, we would write 4.9 times 10 to the third. Okay, because we always wanted to have in 3. That's engineering notation. Scientific notation just follows this, and it doesn't care if you're in the middle of a 3, at the end of a 3, or whatever. So let me give you another example. 723,000. Okay, that's how many people will watch this video because it's so cool. What is that in scientific notation? What you do is you take this number, 7.23, and you go from there and you just count 1, 2, 3, 4, 5. So that's times 10 to the 5. That's it. 10 to the 5 is going to be 100,000. So 7.323 times 100,000 is 723,000. That's scientific notation. Give you another one. It's a bigger one. 602,000,000,000,000,000. Again, this is a pain in the neck to write. So what do we write? We write 6.02. In this case, we go until we run out of numbers. So again, here's the point. From that spot, we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times 10 to the 11th. So it's 6.02 times 10 to the 11th. If there's any numbers after the first one, we just put a decimal after the first one, and we keep going until we run out of them. Then we say times 10 to the to the power. Okay. So one more time, let me explain that. Let's say you have something like 438,902,000. What would that be in scientific notation? It would be 4.28902. I kept going until I ran out. Times 10 to the what? Go back to my decimal point. 1, 2, 3, 4, 5, 6, 7, 8. Times 10 to the 8. That's how you go scientific notation with big numbers. Okay, you'll have a couple of problems that are like that. Let me do, what about if they're small? So, for example, let's say you had 0.00021. Well, similarly, you would write 2.1. So we until we run out of numbers. Well, we ran out of numbers there. And then we count over 1, 2, 3, 4, 5 times 10 to the negative 5. Okay, because it's a 0 point something. 0 point something, that means it's small, and that's what it means. 10 to the negative fifths is tens, hundreds, thousands, 10,000. So 10 to the negative 5 is a 2.1 times 1 10,000 is 21 1,000ths, or 2. Okay, got it? That's how you do it. Give you one more. This would be one that would be typical. You might have something that's 000, 000, 000, 000. There you go. Now that's going to be more or less the weight of an atom in kilograms. And that's small. It's a pain in the neck. Did you lose track of the zeros? I did. So how do we write this in scientific notation instead? Well, we look for our numbers and we put a decimal point after the first one. In this case, it's 6.5. Okay. Then we count. 1, count the 6, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Times 10 to the 23 3, negative 23. That's how big that number is. This is a much easier number to write than this big old long mess. That's why scientists use scientific numbers. Real life, people don't use these, but when you're talking about something that is really small or really big, you must use these. So your homework is going to be from this stuff. And so your homework is going to be on page 219, and you're going to do pretty much all of these problems. And I'm going to just see what you can do. And you're going to go 1 through 39. You'll hit some snags on a couple of the word problems, but I want you to think it through the best you can. So you're going to do all those. That's going to be your homework. Okay. Now, we'll work on what happens when you've got more than one scientific notation and you're multiplying two numbers together. How do you deal with that? We'll do that next week. Since it's a rainy day, this is how we're going to start the new year. Good luck. We're all counting on you. Goodbye.